finish up 6-1. What we're going to look at today is what happens when we get negative exponents or even a zero exponent. Okay, in general, we don't like to have the negative exponents. All right, what we usually want to do is get rid of those as our first step. And then if we can get rid of them, it turns into the kind of problem we were doing on Monday or Tuesday. So we've only been working with positive exponents, right? 2 to the 5th, 3 to the 9th, 5 to the 12th, things like that. We've never had something like this to a negative power. Okay, but because negative power, it's kind of weird if you think about it. What does an exponent, like if I go up a little bit, what does 2 to the 3rd power mean? What does that really mean to do? It means to take whatever's below it and multiply it by itself that many times, right? So like 2 to the 1st power, it means to take whatever's below it and multiply it by itself that many times, right? So 2 to the 1, it's just 2. 2 to the 2nd, 2 times 2. 2 to the 3rd, 2 times 2 times 2. Okay, kind of makes sense. But look at what happens when you have a negative exponent. Take 2 and multiply it by itself a negative number of times. How can you do something a negative amount of times? Like if I said, just make sure you clean the table -3 times. How can you can clean the table 3 times, but how would you clean the table -3 times? So it's kind of weird, right? It doesn't. When we start to get into negative exponents, the idea of multiplying the base by itself a number of times doesn't really make sense anymore. Makes sense for positives, but not for negatives. So let's look at the pattern and see if we can work backwards and figure out what would happen. Right? What is 2 to the 3rd power? How much does it come out to? 8. All right. How about 2 to the 2nd power? 4. 2 to the 1st power? 2. All right. I think we've got enough of a pattern here. We should be able to continue the pattern backwards, even if we don't know how to do these. How did we get from 8 to 4? And it's the same way you get from 4 to 2.
Subtract 4 by.
No, we didn't subtract 4 each time. That wouldn't work.
No, you just
Divide by what?
2.
Yeah, we divided by 2. So to get from here to here, we divided by 2. Here to here, divided by 2. So how am I going to get from here to here? I'm going to divide by 2. So let's figure out what it would be. What's 2 divided by 2? 1. And in fact, I think we talked about it yesterday. Well, kind of talked about it. Anything to the 0 power is always going to be 1. Okay? Doesn't matter if you do, I'll just show you some examples. 5 to the 0 power, 1. 2 to the 0 power, 1. 7 to the 0 power, 1. How about 13 to the 0 power?
1.
1.
Anything negative 26. 26.
What do you guys think? Negative 26 to the 0 power?
1.
1. No matter what. What if you had x to the 0 power?
It'd still be 1.
It'd still be 1. What if you had 3xy all to the 0 power?
Would it be 3?
1.
Oh, so it'd be
That's crazy.
Anything to the 0 power is always 1. Right? But now we want to go a little bit further. Let's go backwards and see what happens when we start getting negative powers. How would you get from here to here? What would you have to do?
Look at your positive and square.
Look at the pattern. What's the pattern been all the time?
Divide.
Divide by what? 2. So you had a 1 here. What do you get if you divide that number by 2?
negative 2.
What's basically saying what's half of 2?
No, half of 1.
What's half of 1? I'm sorry.
Half.
I said 0.5.
You did?
Sorry.
I'll check the tape.
Yeah, check it.
I'm going to check the tape.
Please.
I will.
Yeah. Please tell me.
All right. Next. So, pattern again. How are we going to get from here to here? What are we going to do again? We're going to divide by 2. Divide by 2 just really means to take half of it. So, if you have a half, what's half of that? A fourth. Okay? Now, what if you did half of it again? It would be an eighth. So if I did 2 to the negative third, I would get 1/8. Look at the pattern. 2 to the third, you got an 8. 2 to the negative third, you still got an 8. But where is the 8? In the bottom, right? 2 to the second, you got a 4. 2 to the negative second, you still got a 4. But where's the 4? It's in the bottom. So what do you think that tells you about negative exponents?
They're always at the bottom.
The negative exponent usually means we have an answer in the bottom, right? Because
It's
all
always going to be a fraction.
Yep. So when you have negative exponents like this, you end up with an answer in the bottom. Now, what do you think would happen if you had like a negative exponent, but it was already in the bottom? Where do you think it would go?
In the top.
It would go in the top. So the idea is anytime we have a negative exponent, if it's in the top, like it is in all the examples here, it goes to the bottom. If it was already in the bottom, it has to move to the top. That's basically the rule of how we're going to deal with negative exponents.
Guys, on your notes, you have up until thus we can see, and you're going to write any non-zero number or variable raised to the 0 power is 1.
The only special case that's kind of weird is this one, because technically, if you look at the pattern, we've seen so far that anything to the 0 power is 1, right? Well, if we take, let's say, 0 to the 8th power, 0. 0 to the 78th power, 0. 0 to the 5th power, 0. How about 0 to the 9th power? 0. So it looks like whenever the base is 0 and you raise it to a power, you get 0. But we said earlier, whenever the exponent is 0, you should always get a 1. Well, now it's like these two things are fighting each other, right? When this is 0, you should get a 0. Because 0 to anything, right, should be 0. But when the exponent is 0, it should come out to a 1. So which one is it? Well, actually there is no answer. You can't do 0 to the 0, and if you try...
Do it.
What? Tell me what to do. Alright, if you do 0 to the 0 power, just clear this out. 0 raised to the 0, right? You're thinking, alright, 0 exponent should come out to 1. 0 base says it should come out to 0. Doesn't come out to either. Error. Can't do it. Okay? It's kind of like dividing by 0. You can't do it. Just can't do it.
There's no possible way.
Right. But I don't think you guys are going to run into a problem where we have 0 to the 0. It's most of the time it's going to be a number or a letter to the 0.
Remember, guys, even if it's a variable or a letter to the 0 power, it's still going to be 1. So that rule works just like every rule we've talked about this week. It works for a letter or a number as the base.
All right, so let's look at this. 4 to the 0 power.
1.
It's going to be 1. Don't even have to think about it.
Make sure you get that example on your notes too.
Okay, 4 to the 0 power, 1. How about m to the 0 power?
One.
M to the first power would be m. What's m to the 0th power? 1.
Like I said,
What
all the
happened to the M?
Remember, anytime, that's why we looked at
doesn't
this.
matter what it is.
That's why we looked at this pattern. Anytime you raise something to the 0 power, it's always 1. I could do this pattern with 2s, I could do it with 3s, I could do it with letters. That's the rule. Anything to the 0 power has to be 1. If it's not, it wouldn't follow the pattern.
I am paying attention.
It's got to follow this pattern, right?
So sometimes it's confusing. Sometimes it's
Oh my
gonna
gosh.
Yeah, because there was a whole variable there. I know what's going on.
Yep, well,
It works with letters and numbers.
it's kind of like if I said, what's x times 0?
0?
0.
No, it's 1.
Well, what happened to the x?
That makes sense.
Where'd the x go? It's gone, because when you multiply something by 0, it disappears. When you raise something to the 0 power, it disappears. It just becomes 1.
That's how the ball bounces.
That's the way the news goes.
Alright, so we got to look at what happens when we have negative exponents. Okay, I'm going to go through like some of the simple ones. I think Mr. Roy will go through like the multi-step.
Yeah.
He'll go through those steps with you.
Sure.
But we got to figure out, just with simple ones, how do we deal with a negative exponent? Okay, so if you have a base with a negative exponent, okay, You move the base with the exponent. They're a package deal, all right? You can't, if you got something like this, that's one unit. It's all stuck together. The base and the exponent. You can't separate them.
Yep, the exponent to the top right always belongs to the base.
So you've got to take that whole package deal and you've got to move it to the opposite place in the fraction. So what that means, if you had a negative exponent in your problem and it was already in the top, you want to make it positive, move it to the bottom. If you had a negative exponent in your problem and it was already in the bottom, well, you've got to move it to the opposite place in the fraction. Put it in the top. And it doesn't mean you have to move everything in the problem, right? Because if you've got something like, I just need some space here. Don't worry about writing yet. I just want to show you this. There's only one problem with that. There's only one thing there that I don't like. X cubed, I like it. Don't move it. It's fine. 2, I like it. It's fine. Don't move it. The only thing that has a problem is this. So if we were doing this problem, that is the only thing that would move. The 2's not going to move. The x cubed isn't going to move. Just the thing that I circled. Okay? Because if you move something and it already had a positive exponent, what do you think you would do to it? You'd mess it up. What would happen to it? It would become negative. You don't want to do that. If you say, oh, I'm going to move this x cubed to the bottom, well, now you just messed up the x cubed. You made it negative because you moved it. It was already positive. You shouldn't have moved it. Okay?
And guys, with this, something like this, just be careful. If we gave you something like this, that's fine too. Because, again, we're only moving negative exponents. My exponent with my negative b is positive 3. My exponent with my c is 5. The base is negative, not the exponent. So let's be careful. Now you may get something like this, negative 3 to the negative 3. So we'll talk about that. We'd have to move that, but it doesn't make the base positive. By moving the exponent to the opposite, the base to the opposite place, it only makes the exponent positive. It doesn't make the base positive. So just be careful. I see some people get slipped up with that. If you have a negative base, that's going to stay negative. The only thing you can make positive by changing its location is the exponent. Just be careful, because we'll give you something like that have a negative base and a negative exponent.
Yep. And whether you did that problem like this or like this, we have to be careful. Okay. We'll talk about that.
Like the next bullet says it there, guys. If the negative exponent is in an expression, put the entire expression over 1. So if it's not already set up as a fraction, if it's not already set up, you may get problems where it's not set up as a fraction.
Like the one I circled right there, x to the negative 3.
Yeah, like that one's not set up as a fraction. You can make it a fraction, like the directions say. Put it over 1. Then I can take it, I'll just change the location. I'm going to move my base to the bottom. The base stays the same whether it's positive or negative. And by moving it, that's what makes the exponent positive. Move the 1 to the top. So this right here, if we gave us a question like that and said simplify and make sure all exponents are positive, then that would be your answer right there. All you have to do is just move it and it's done.
Think of that fraction line. It's kind of like a filter. Anything that moves through that fraction line, all of a sudden it changes. It takes whatever the exponent was and changes it. If it passes through the filter and it was a negative, it comes out positive. If it passes through that filter and it was already positive, that's a problem. Now you're going to make it negative. Okay, so anything that passes through that line changes the sign on the exponent.
Now, if it's already set up as a fraction, great, you don't have to worry about it.
Okay, all other rules that we learned still apply.
Power to a power, multiplying exponents, dividing exponents, all that stuff. We may get problems and have, again, like I said, same steps as yesterday, we're just going to add one more.
I'm just writing it in
Yeah.
case you can't see it. It's x to the negative 6.
Guys, I know there's a spot for example 1C on your notes, don't worry about that. We're in 2A right now.
So just like not,
You can cross it out or just leave it, doesn't matter.
All right, so now we've got a problem with a negative exponent. Not what we want. Okay, we've got to turn it positive. Changing it involves moving it in a fraction. I don't have a fraction, so how can I make a fraction here? Yep. Put it over 1. And now tell me the thing we've got to move. What's the thing that has to move here to become a positive? Yep, done.
Negative 6.
More than that, we got to move something else.
Negative 6.
The whole thing.
The base first.
This whole thing is going to go with it. Where is this whole thing going to go? That's going to go on the bottom. Now, when you do that, what's left in the top now?
1.
We're moving everything that's there, but you can't leave it empty. You got to put something.
Put a 1.
Yeah, put a 1.
Because I guess we were doing like the division stuff. If there's nothing on the top, we could just put a 1 that kind of like to hold the place.
Okay, so we put a 1 in the top because there's nothing left there. Now we have this 1 in the bottom, but we only put the 1 in the bottom because there was nothing there. We're going to have something there now. What's going to be in the bottom?
X and then negative 6. X to the X.
X to the 6th.
No negative.
No negative. That was the point of moving it. You move it, it gets rid of the negative. Okay. Now, technically, this 1 is still here. If you want to put it, you can put it right there. I'm usually not going to write it. Okay, 1x to the 6th. If you want to write it, you can. Okay. I would probably just write it like this. Okay. Any question on that? Now, because that's a letter, there's nothing else I can do. If it's a number, then there is more I can do. Okay, you got to actually use your calculator or figure it out at the end. Okay, so that's 4 to the negative
Just like we said
2.
yesterday, if we have a whole number that has a variable attached, we have to simplify it. Use the caret button on your calculator.
All right. So, what's the first thing I have to do with that? Put it what? Why am I putting it over 1? Because I need to flip it. If I don't have a fraction, I have nothing to flip, right?
As soon as you see a negative exponent, put it over 1. As soon as you see an expression with a negative exponent, whether it's 1, more than 1, doesn't matter. Put a negative, put it over 1.
So what has to move here?
The 4 and the negative 2.
The 4 with the negative 2. Package deal. They go together. Where does it have to go? It has to go to the bottom. Okay. Now again, another example where everything that was in the top is gone. Okay? That's not always going to happen, right? But in these 2 cases it did. So what's left in the top? 1. And what's going to be in the bottom? 4 to the 2nd. Now, because these are numbers, we can take it one more step. What is 4 to the 2nd? 16. So the answer here is 1/16.
Guys, on your notes, Brady just pointed out a little typo to me. For the second one, it says 2C. Just change it to 2B. I know some of you guys already did.
Okay, everybody, you get that one?
Alright, so guys, like we talked about a little bit yesterday, the steps, and that's why on your notes, if you look, even on the back side, there's no space for the steps. I'm not going to make, Mr. Hager and I are not going to make you rewrite it. You wrote 5 out of the 6 steps yesterday, alright? Just make sure you know that, or go back to when you're doing your reference sheet, just go on to Math with Hager, you can copy these down. Alright, there's only going to be one step that's new today.
What if you like went to your papers and used that?
You can do that too, but just make sure one of these steps we're not writing down today, you're just going to make sure you know which one it is. Alright? So, like I said, all the other steps are going to be the same, and like we set up here, there's going to be a spot on your reference sheet on the front side where you can put all these steps. And the reference sheet is up on Google Classroom. So if you want to start filling it out, you can. Remember, it's optional. You don't have to fill it out. But again, I think these steps would definitely be helpful for you guys because there's so many different things with the multiplying, when you add them, when you subtract them. So it might be something good for you guys at the least to put on your reference sheet. But again, it's up to you. All right? So first step is the same as yesterday. Does anybody remember what the first step was? This one doesn't change. Anybody remember? When you have parentheses, then you have an exponent on the outside. Anybody remember? Savannah? Yeah, power to a power. Again, you don't have to write this down. We're just going through it. So power to a power, if possible. You may not have it. And even if this number, the exponent out here is negative, or any of the exponents on the inside are negative, right, we can still multiply it. We'll move them after. Right? It'll make more sense to do power to a power first. If we have a negative, then we can move it after. All right? Step 2, that's going to be the new one. So if we have power to a power, we'll do that. If not, we'll move to this step. If we have negative exponents, but this is a new thing from today, we're going to move them to the opposite spot. All right? And that'll move the base, and then that'll make the exponent positive by putting it in the opposite spot. It's on the top, when I move to the bottom, it becomes positive. It's on the bottom, I move to the top, it becomes positive. Remember, if the whole number, or the base, is negative, it stays negative. The only thing that becomes positive is when you move the exponents, not the base. The base is negative, it stays negative. The base is positive, it stays positive. All right? Third step, if we have any whole numbers, all right, that have exponents attached, I want to simplify them. Whether, if it's to the second power like this, you might be able to do it in your head. If not, use your calculator. Remember, if the exponent is negative, how are we going to make sure we put it in our calculator? Put parentheses, right? If you don't, it'll come out wrong. If it's a positive base, it doesn't matter, right? You can put it in as normal. If it's negative, you got to make sure you put it in parentheses. 4, right? Step 4. If we have exponents that have the same base on the same level, all right? Keep the base, add the exponents. Like if we had x to the second, x to the fifth, over y3. They're on the same level. I keep the base. I add the exponents. 5 plus 2 is 7. All right? That's just an example of that. And this is like, the rest of these are, the only step that was new was number 2, step 2. Next, we'll subtract exponents with the same base on different levels and put the base and positive exponent where the bigger exponent was. It's a lot to say. Basically what it means is y5, y3, it would be y to the second. I mean, I could put it over 1, but it'll still end up being y to the second. 5 is bigger than 3, that's why I put it on the top and I just subtracted. Okay? Last step, reduce numbers if possible. So if I still have whole numbers left, like a 4x to the second y, 2z. I can reduce that and end up being 2x to the second y over, we can put 1z or we can just put z. I reduce that by 2, right? 2 goes into both, or we can look at it as 4 divided by 2 is 2. Just going to make sure. That's kind of like the one thing that you just need to know how to do. You need to know how to reduce those whole numbers. It's not a skill that we're like teaching you new this week. You just have to know how to do it. All right? So those are the steps. Again, you'll have a spot on your reference sheet to copy all those down. We wrote 5 out of the 6 yesterday. The only thing that's new is step 2, moving the negative exponents. That's the only thing. All right? So let's look at 3a. Now, we didn't put this step on what we just talked about. We talked about this a little while ago. I have a negative exponent, and I don't have a negative exponent, and I don't have, it's not in a fraction. So what should I do? Put it over 1, right? So I'm just going to take this whole thing, I'm going to put it over 1. I know that's not one of our steps, but we just got to make sure that if we see a negative exponent, we got to make sure we put the whole, if it's not a fraction already, put the whole thing over 1. All right? Another thing I see there that we've talked about today, but we didn't talk about it in our steps. Anybody see that one thing there that we've talked about today, but we didn't talk about it in our steps? So one thing is, we have a negative exponent, put the whole thing over 1. What's the other thing there that we talked about today, but it's not in our steps? Chris?
The 0.
The 0, right? Anything to the 0 power is what?
1.
What I would do personally, guys, I just take, this doesn't matter anymore. It's 1. We can just cross it out. Because what it means is negative 3x to the negative 4 times 1. It's still gonna be the same thing. So if you have anything to the 0 power, that's included in an expression like this, just cross it out. It's gone. You're just multiplying the thing by 1. It's gonna end up being the same thing. All right? So we did that. Our first step when we just wrote down was what's today? You already told me. The first step we're looking for. Power to a power. I have to have parentheses for that, right? Alex, do I have parentheses? No parentheses. All right. What was step 2? Anybody remember? What was the second step we talked about? That was new today. Yusuf?
So you put the 1 at the top, right? Or like you have to switch it.
Flip it. Okay. What base am I moving?
Are you moving negative 3 x?
Careful. Now, even though it's not written there, Yusuf, what's the exponent with the negative 3?
Oh, a negative.
No.
I mean, that's x. Wait, x1?
Yeah, what's the exponent with negative 3? Even though it's not written there.
Oh, 1.
1. Is 1 positive or negative?
Positive.
This is what we talked about before. Yusuf brings up a good point. Be careful. The base, negative 3 is the base. It's not the exponent. The exponent's still positive. It's a positive 1. Do I need to move that? No. So that negative 3 can just stay on the top. Remember, we're only moving negative exponents, not negative bases. Even if I have a negative exponent with a negative base, the base will stay negative. The only thing that becomes positive when you move it is the exponent. All right? So I handle the negative 3. Step 2, we said we want, this is in step 2, this is when we're moving our negative exponents to the opposite place. So, what do I have to do? Yusuf?
Now you have to bring down the negative 4 to the bottom.
Bring down a negative 4, so what's attached to the negative 4? X. X moves to the bottom, and what happens? Negative 4 becomes positive 4. Alright? The y to the 0 is gone. It's just 1. Well, that means just multiply what's on the top by 1. It's going to stay the same thing. Alright. Next step was any whole numbers with an exponent bigger than 1. Do we have that?
No.
No. We have a whole number, but the exponent's 1, like you just talked about. We don't have that. Same base, same level. Do I have it?
No.
No. I don't have different bases on different levels, and there's nothing that I can simplify or reduce. This is my final answer.
Oh.
I think, and guys, just pay attention to what your directions say. Simplify, use positive exponent. I think on the test it'll say like simplify, assume there's no negative exponent, something like that. So this right here is your final answer. All right? negative 3 over x to the 4. We only had what? We had, two of the steps we didn't talk about in what we wrote down. If we have anything to the 0 power, cross it out, and if we see a negative exponent, put it over 1. All right? So that's it. That's all I have to do for that one. Let's look at 3b. All right? Now this one is a fraction, so I don't have to put it over 1. All right? First step, power to a power. Miguel, do I have power to a power? No, because I need to have parentheses, right? There's no parentheses there.
Is that an 8 at the bottom?
This is negative. This is 7 to the negative 2, t to the negative 5 over r to the negative 8. Yes. All right. So I don't have power like Miguel just said. There's no parentheses, so there's no power to a power. Look on my line. I got nothing to the 0. There's no whole number or variable to the 0 power, so I don't have to cross any of those out. Right, so now I'm at the part where I have to move some stuff. Flip everything. So can someone tell me what's going to move? Paige, what's one of the things that's going to move to the bottom? So is there anything on top that has negative exponents? Okay. So what's one of the bases that has a negative exponent? 7, right? So I gotta take it, where does it go? From the top to the bottom. What happens to the exponent page? It becomes positive, so it'll be 7 to the second. Brady, what else is gonna move to the bottom? Remember, anything that has a negative exponent has to move to the opposite location or the opposite place, and that will make the exponent positive. So 7 had a negative 2, right? We moved it to the bottom, it made the 2 positive, right? What else do you see on the top?
Negative 5.
Negative 5. So what happens? So what am I going to write on the bottom?
I don't know.
What's the base? This is a T.
It's T, right?
Yeah.
T.
T.
And that'll be positive 5.
T to the positive 5. All right? Ryan, what's on the bottom that's going to move to the top? R to the 8, right? It's negative here. I move the base, and I make the exponent positive. All right. Next thing in our step, do we have any whole numbers with exponents attached? Dylan, do we have any whole numbers with exponents attached? What number?
7.
What's attached to it?
2.
If I was to simplify that, what would I get?
49.
49. Very good. 49 stays on the bottom. Once I've done this, nothing moves again. 49, T5, R8. Same base, same level. No, right? I got an R, I got a T. Nope. Different, same base, different levels. I have an R, I have a T. They're not the same. Last step, reduce. I only have one number, I got a 49. Nothing I can reduce it by. This is my final answer. So that one had two steps. I had to move the negative exponents, and I had to simplify the whole number with the exponent attached. This one, same deal. It's already, I'll scroll back a little bit so people need to finish writing that one down. It's already a fraction. I'll give you guys a second to write it down.
Is that a Z or
It is -4 to the -2, z to the 0, y to the -7, and on the bottom, 2x to the -3.
Mr. Ray, is that -4 in parentheses or not? Because it'll make a difference on our answer.
It's not in parentheses.
Okay. So then that negative 2 then only applies to the 4. It doesn't apply to the negative in front of it. If it was in parentheses, it would apply to both. And that's when you have it to an even power and it cancels out. That's not going to happen here.
Alright, so with this. So I guess I'll call it like we have an unspoken rule here. It's one of the rules we didn't write down, but it's something we need to know we have to do. Something's gonna change here or something's gonna cross out. What is it? Yusuf?
Just cross out Z and 0.
Z to 0, right? Because it's gonna be 1. That means I'm multiplying everything on the top by 1. It's not gonna change, it stays exactly the same. So I'm just gonna cross out that Z to the 0. Anytime I see a number or obviously if this was isolated and we said like this, we asked you to answer it, obviously you write 1. But where it's like embedded in an expression like this, you can just cross it out. But if we're asking you something like this, you want to put an answer with 1. So just be careful. Alright? So again, Yusuf just said that was kind of one of the rules I call it an unspoken rule because we didn't write it down. Or unwritten rule. We're just gonna know if we have anything in the 0 power that's embedded in a problem, cross it out. Because we're just multiplying by 1. Alright? So, first step, power to a power. Gigi, do we have it? No. Right? There's no parentheses. There's no parentheses there. So now I'm at the spot where, again, the new thing today, where I want to move exponents. G, what's one of the numbers or letters I have to move?
-4.
-4. Where am I putting it?
On the bottom.
On the bottom. And tell me what to write.
-4 to the second.
-4 to the second. Perfect. Because that negative doesn't change. Like Mr. Hager said. The -2 is only worried about the -2 with the 4. Not with the negatives. The negatives just coming down. You want to leave that negative up top or bring it down? Doesn't matter. What's something, Nathan, what's something else we need to move?
Line.
So tell me where it's going to go and tell me where to write it.
Line -7.
It's on the top.
That should be on the bottom.
What do I write?
Y to the 7.
Y to the 7th, right? Because by moving it, that's what makes it positive. Alright? Anything else that needs to move? Nicole, what do you think? Anything else that needs to move?
The bottom, the 2x, 3x to the top.
So I'm moving 2x to the -3 on top. So then I see you shaking your head. Why?
Because the 2 has a 1.
Yeah. Remember, the 2 has a exponent of 1. So 1 is positive. I don't need to move this. I can just leave it as 2 on the bottom. But I agree with the other part of what Nicole said. The x to the -3 needs to move from the bottom to the top. Right there. Alright? So I did that. Are there any, like Mr. Hager said, the negative's kind of just floating there by itself. It's not really attached to the negative. It's like this. So I'm only applying that to the power of 2 to the 4, not the negative. Right? That's just staying on there. It's not part of it. Like Mr. Hager said, if it was like this, then it'd be a different story. So if it's not in parentheses, it's just kind of floating out there. We're just going to bring it over. It's not attached to anything. All right. So now, do we have any whole numbers? Melanie, do we have any whole numbers that have a variable attached?
No. Wait. Yeah.
Anybody see a whole
Wait.
number? Hold on,
Wait, what do you mean?
Like a big number, like 3, 7, 5, that's got a variable, that's got an exponent attached.
No, we have the -4, right?
Well, actually, like I said, that negative is just floating. I can take that negative and bring it over here. And then we don't have to worry about it. I just brought it over. So I have a whole number that has a variable attached. Like Yusuf said, how'd you get 16, Yusuf?
4 times 4.
Yeah, 4 in the second, right? Remember, that negative is kind of floating out there. It's not part of the 4. If it was inside the parentheses, it would be, but it's not written that way. So it's just going to be like Yusuf said, 4 times 4, 16. All right? Everything else, I'll bring over. X to the 3, y 7, 2. Same base, same level. I got an x on top, there's nothing else. I got a negative 16 on the bottom, I got a y, and I got a 2. None of those things are the same. All right. Do I have different bases, same base, different level?
Yeah, X.
I got an x, do I have another x down here? Where?
No.
No? I got a y, I got x's and y's, I got negative 16, nothing else. All right. Is there anything that's maybe not,
Oh,
what are you saying?
the negative 16 and 2.
Yeah, what am I gonna do with those two things, Yusuf?
That's a bad question to ask.
Because is there any sign, like, think if it was like this, like say if it was 2 to the x, what operation does that represent? Multiplication. So there's no plus or minus sign on the bottom here. So what do you think I'm gonna do? Multiply. I'm gonna do negative 16. I'm doing negative 16 times 2. Positive times a negative is a what? Negative. It'll be negative 32. Y to the 7th. I just bring that over. All right. I have a number on the bottom, negative 32. I have no other number on top. So there's nothing there I can reduce. Now, if there's like a 2 on the top, then I can reduce both the top and the bottom by 2. I can divide 2 by 2. I can divide negative 32 by 2. But I don't have that. This is it. I'm done. So that one was a little, again, we didn't have that step written on our notes or on our steps that we wrote. But again, if you got 2 whole numbers on the same level, just multiply them together. That's how we got the negative 6. That's what we did, the negative 16 times 2. That's how we got negative 32. So if you have 2 whole numbers that are on the same level, just multiply them together. All right? Good with this. All right. Now these are quick. These are quick. Don't be done. All right. So I know I have a negative exponent. All right. For right now, let's hold off. Let's hold off on putting it over 1. Now, how many, I guess, terms do I have on the inside of the parentheses? 2. Remember, these things are separate. A 2 and the A aren't a package deal. It's 2 and it's A. They're separate. When you're doing this kind of stuff, you got to think of it as 2 separate things. Now, neither one has an exponent written. What can I do? Put a 1 with both. 2 to the first, A to the first. What do I need to do now with that negative 4? Multiply by what, Yusuf? Am I multiplying the negative 4 by 2, the negative 4 by the A, or by the 1s? By the 1s, right? This is power to a power. Multiply the exponent on the outside by the exponents on the inside. My bases don't change. I mean, if I see that, I can write my bases right away. My 2 and my A. Catherine, when I do power to a power, what exponent is going to be attached to the 2 now? Now, 1 originally, careful, almost, -4. So I'm doing -4 times 1, which is -4, right? What's going to be attached to the A? -4. -4 times 1, -4. So I just did power to a power. Now I'm seeing negative exponents. So what do I want to do with the whole thing? Put it over 1. What happens? Flip it, right? So, Alex, what's going to be written on the bottom now? 2 to the 4th power, okay? You're almost there. A to the 4th. Keep the base to A. Make the exponent, by moving it, you make the exponent positive. I got nothing on the top. 1, right? If I can run into a situation like that, let's put a 1 there to kind of hold the place. Do I have... There's only one more thing I have to do in this problem. What is it? Yeah, 2 together 4 times. I can use my calculator, 2 caret button 4, or 2 times 2, 4 times 2 again, 8 times 2 again, 16. Again, remember, it's not 2 times 4, it's this number multiplied together that many times. Again, I think for you guys, I think it's when it's to the 2nd power, you can handle it. But if it gets like to the 3rd power, 4th power, more than that, I would recommend using your calculator. If it's a small base like 2, you may be able to do it. But if it gets bigger than that, you may want to use your calculator. So that's like we said, it's going to be 16, A4. That's your final answer. All right? This one, same type of deal. But instead of having, it's a little different, this one had 2 terms, this one only has 1 term. Right? We're still, the only real difference, 1 term, and we have a number on, well, this one had a number and a letter, this one only has a number. All right? So when I do power to a power, what am I going to get? Can someone tell me? When I do power to a power, what am I going to get? Does my base change? No. What's my base? 7. That doesn't change. What's the exponent going to be when I do power to a power? Say it, Nicole. -2. -1 times 2 is -2. So I get 7 to the -2. What should I do now, Donovan? Huh? What's that mean?
7 times 7.
Careful though.
-7.
I get the -2, right?
Oh, you want to, what's it called? Put it on the bottom.
Put it over 1. Well, you can put it over 1 first. Then what do you mean put it on the bottom? What am I going to write on the bottom?
7 positive 2.
7 with a positive 2 because it changes it, right? Anyone know what that simplifies to?
49.
49, right? On the bottom, on the top, 1. Right? So I have 1 over 49. All right? This one, I'll just do it out real quick.
You're changing.
Yeah. All right. We'll do it like that, right? So now we have parentheses around the whole thing. So I'm doing power to a power to the whole thing. All right? I'm gonna have a 1 here. I'm gonna have a 1 here. So I'm gonna multiply the -2 to the exponent on the top and the exponent on the bottom.
So then wouldn't it be x -2 and 2, -2.
Perfect. X, -2, 2, -2. Nothing happens with the bases. I'm only multiplying the exponents. Alright? What happens now? Flip it. What's going to be on the bottom, Nicole? X to the second. By moving it, it makes it positive. David, what's going to be on the top now?
2 positive 2.
2 positive 2. Keep the base. Make the exponent positive. One last thing.
4
4 on the top or the bottom.
on the top.
And nothing changes. 2 times 2.
4 and then
4.
would be
X2. Nothing changes. Alright? So in those last ones, the last couple we did there are power to a power, but when you're dealing with a negative. Alright? People have all this stuff? Homework. Actually, it should say like worksheet, whatever. It's gonna kind of look, when you get the homework tonight, guys, it's gonna kind of look like the test review. I think, and it says on there, I want to say like the first 7 or 8 questions are kind of like what we did today. But again, obviously, you have to know all of the other rules, and then like the rest of the stuff will be a review of stuff we did on Tuesday and Monday. All right. Tomorrow, review day. Probably gonna be somewhere in the ballpark of like 6 to 9 bonus points possible tomorrow. And it's gonna talk to Mr. Hager about how he wants to do it. So you're good. A possibility of 6 to 9, that's the maximum you could get.
He's not gonna do that.
Alright? So guys, just understand, tomorrow night's homework is gonna be online. Right, it'll be on Big Ideas. It'll be a review of all the stuff we've done this week, it'll just be on Big Ideas.
I hate doing that.
Reference sheet, I put it up yesterday. Like we said, it's not required, but writing down all those steps, it's a spot to write down all those steps, it may be helpful for you. You want to fill out the whole thing? That's your choice. You want to fill out nothing? That's your choice too. We don't count it as homework anymore. Last thing, both of us. I'm going to be here until 3:45 tomorrow. Right? Any questions about any of the stuff we did this week? You ROTC people, you're kind of lost by missing a day yesterday. Get here after school. Alright? Look, time's running short, right? I've told you 100 times. You don't want to do what you can do now during the summer. Because you're going to drag your butt out of bed. It's going to cost you $250. And you really don't want to be here. So take advantage of the time now. There were some practice problems, guys. I'm not going to make you do those.